Hi, everybody. This is Dr. Collins. So a little bit weird. This is the first video. So I'm hoping that this will be a nice journey for both of us, right? It's not going to be super easy for any of us. It's a weird scenario, but it's a little bit freeing as well, right? I may or may not have a glass of scotch next to me. I may or may not be wearing pants, right? Either way, it's a little bit freeing. Don't get too comfortable though, because we are hoping to get back to a regular schedule as close as possible to normal probably next semester, but hopefully we'll get there at some point. Online learning isn't perfect. There's still a lot of kinks to work out, but hopefully at this point, we're going to make sure that we get you through the rest of this course. Now, a number of you have expressed some concerns about connectivity and the ability to make live classes. So instead, I'm hoping that I will be able to offer these asynchronous videos, that is, not at the same time as you're online. So you can use them at your normal pace, right? Whatever works for you. Okay, so as we see here, right, we're going to start with correlations. All right, now correlations, as you can see, there are some funny ones we've thought about before. Here's a fun one, right, that you can generally see right here, where you see that the rate of Internet Explorer market share correlates with the murder rate, right, which is kind of fun to think about. Okay, all right, now we're going to start by talking about what you may already know about correlations. Then we'll think graphically, apply graphics to the idea of correlations to try to clarify what we mean by these things. And then we will talk about positive versus negative correlations. And then we'll move on to the nitty-gritty, right? The really mathematical stuff. How do we measure correlations? How do we interpret them? Okay. So this video, right, which is the first of two about correlation, and then I'll have a demo as a third video, are just going to focus on those first three. Okay, so let's dive in. So what do you already know about correlations? Probably more than you think. In plain English, what is a correlation? I'll give you a minute to think about it, right? Sort of feels like Daniel Tiger. Here, you think about it for 10 seconds. Well, at its most basic level, it means that two variables are somehow related, right? Murder rate, Internet Explorer market share, death by drowning in pools, number of Nick Cage films, right? Things that we've talked about in class before. Okay, so at its most basic level, it does mean that two variables are related. In other words, they vary together, right? As one increases, so does the other. Maybe the other one decreases, right? But they do vary in similar ways. Generally, though, we do only use correlations for two continuous variables, right? Recall when we talked about levels of measurement, right? We had the lowest level of measurement was that nominal level, then ordinal, then interval and ratio. And interval and level and ratio levels, those are the variables where they contain a lot of information. The numbers themselves actually matter. That's what we can use correlation for. We can't really use it for ordinal or nominal level variables. Theoretically, you can, but it's not really best practices. So what's the range on a correlation? You probably already know this. That's right, it's -1 to +1. Okay, runs through 0, -1 to +1. That's the bounds. But what do these actually mean? Okay, that's something that we'll think about. All right. Now, what doesn't correlation tell us? When we talk about correlation, we often hear that correlation is not the same thing as causation. That's right. Right. So here's a fun graphic from XKCD Comics. So hopefully, right, this course will help you appreciate that a little bit more. Okay. Now, let's think graphically. Okay. Now, this figure is what's known as a scatter plot. Okay. A scatter plot shows you the relationship between two variables, right? Each observation is one of these little dots. Okay, that's one observation. And in this case, it's quarterly presidential approval and quarterly unemployment, right? So here on the x-axis, we have quarterly unemployment, and here on the y-axis, we have quarterly presidential approval from 1978 to 2006. Okay. Now, when you plot this out, each of these represents one quarter, right? It could be a quarter of 1978, first, second, third, fourth quarter. It could be 1979, first, second, third, fourth, right? So on and so forth. Now, if you look at these, you'll notice right? We have a handful of cases that are really high unemployment, okay, and relatively low, probably below the mean of presidential approval, okay? Now, to what extent do we think that's going to weigh on our correlation, right? We'll certainly see that. For now, of course, right, we have potential options. If you were to draw a line to represent this relationship, you might draw one just completely disregarding those outliers over on the far end of the screen, and you might draw a line that looks something like this, okay? Maybe it would look something more like this. Maybe you don't want to disregard those outliers, right? Maybe you say, I think those are important, so I want to draw a correlation that maybe looks something like that, okay? Those are all valid options, right? So think about the blue, the yellow, and the red, okay? Now that red is a little more gradual. And of course, as you're probably already figuring out, the red is more accurate. It's not perfect, but it's more accurate. Now, positive versus negative correlations. Now, if you assume the red one was closer to reality, which again, I just told you it was, right? What kind of relationship is that? What direction is that relationship? As unemployment increased, what happened to presidential approval according to that red line? Put it another way, what's the slope of that line? Is it positive or negative? That's right, it's negative. Okay. So as one increases, right? This one increases, so does this one. Okay. That's a positive correlation. Sometimes we call it a direct correlation. The reason for that is positive sometimes connotes good, right? We don't want to evaluate normatively how good the relationship is. Instead, right, we want to make sure that we're describing it mathematically. Right? A direct relationship says as this one goes up, this one goes down. Okay, so sometimes it's called a direct relationship. I'm inclined to just call it positive and negative correlations. Okay, but your textbook may use direct and indirect as well. A negative correlation, right, is one where as the x variable increases, the y variable decreases. Okay, so you can see that difference, right? So as one increases, the other decreases, and vice versa, right? As one decreases, the other increases. Okay, the idea is they're going in opposite directions from one another, right? So that's called a negative because the slope of this red line here is negative, and the slope on that last slide was also negative. This is sometimes also called an indirect correlation, direct, indirect. There's one other option though, right? They could be uncorrelated, right? You could have just straight up no relationship, right? A correlation of exactly zero, where there's no relationship between these two variables, okay? So that wraps up this video, but to review really quickly, right, let's recall that a correlation tells us how closely related two continuous variables are, right? The higher the absolute value of that variable, the higher the correlation, right? The higher the absolute value of that correlation coefficient is what we're going to call it, the higher that relationship is, the stronger that relationship is. Now we can think about these two relationships graphically, right? We can think about it as positive versus negative, right? We can think about them as having no correlation at all, okay? Generally, they are positive or negative. They could also be no correlation. Now next, right, in the next video, we're going to talk about how do we measure correlations? How do we measure a correlation? Well, your textbook gives you one way. I'm going to show you another way that I think makes a little more intuitive sense in describing what a correlation really is, okay? And then finally, how do we interpret these correlations? And then the third video is going to be more of a demo, walking you through the steps to calculate this. All right, so hopefully this video worked out for you, and I'll see you next time.